This week we're going to spend some time on PCB design, and the first tutorial that you guys are going to follow is from this channel on YouTube, Great Scott, that I think it's very high quality content. It has very high quality content, and this tutorial is about how to design the PCB from schematic, layout, and then generate the Gerber files. So it gives you a couple of steps, or it gives you a set of steps that you can follow when you design PCBs. Step number one, the planning of the function of your circuit. Sketch the block diagram or a paper schematic. Like, what are you trying to achieve with your PCB design? This is a high level kind of design. You put that you need a microprocessor, you don't know yet which one. You need to transmit your signal over Wi-Fi, interfaces with the joystick, you need some sort of regulator here that comes from a battery and then charge that battery. Kind of a highlight of what you want to achieve with your circuit. Step number two is component sourcing, where it's divided in three other steps. The first one is check for suitable components and respective sizes. So you're going to use Mouser, DigiKey, or any other website that sells this type of components. You're going to check which components are available so you can order, and respective sizes. So which type of resistors or capacitors you want to solder in terms of sizes. I normally recommend a 0603 or a 0805 size. Those are good and easy, manageable to solder. When you start going lower than that or smaller than that, it becomes a little bit harder. The next one, check packages. Check if you want to do surface mounting components or deep components, through hole components. And then update your paper schematic. So after you do that, go back to your paper schematic, and now this time go and update the modules or the blocks with the name of the IC that you're going to use, as you see over here. Step number three, create the proper schematic. These guys use a CAD software. We're going to use Eagle, but you can use any other software. I'm going to support only help on Eagle because that's the one that I use. It's free. And if possible, when you're designing that, arrange the schematic by logical blocks, meaning separate your schematic where you have things related with your power block in one section, things related with your microprocessor in another section. I give you here another example where I have the microprocessor done here, the regulation stage done here, the 5 and the 3 with the comparator and the USB to serial converter. So notice how things get organized and easy to follow. Step number four, after you do the schematics, you go to your PCB layout. There are also a couple of steps that you can follow when you're doing PCB layout. The first one, you place your components without tracing any of the routes. Just place them in a way that makes sense to you, or if you have a package limitation or size, you place the components according to that package. And then you trace the routes, and here you have different layers. We are going to, normally 2 layers is more than enough for the stuff that we do, but you can have 2, 4, 16, 8, any amount of layers. The more layers you have, the more expensive the PCB is, and the harder, more complex it is to build. So, and even routing. So normally for what we do, two layers is more than enough. And then at the end, add a copper ground layer. And after this, a couple of kind of guidelines, design guidelines. A big question that is normally asked is, should I use 45 degrees or 90-degree angles on your traces? Well, the answer is, does not matter. You can use whatever you want. Back in time, in terms of manufacturing 90-degree angles was hard. So that's why we do like more smooth angles. But there is also some thoughts that 90 degrees, you have more electromagnetic interference from your waves. I highly recommend you guys to read this article. They kind of debunk that myth. They do a couple of tests, and they reach to the conclusion that if you're not doing high speed stuff like RF signals, 10 gigahertz and things like that, it doesn't matter what you do. In terms of aesthetics, it's probably better like to do the 45 degrees, and that's why people normally do it. In terms of width of the trace, this is important because your trace is going to carry current. If you do a too thin trace, and then you put like 5 amps on it, it's just going to act as a fuse. You don't want that. You can use tools to help you calculating that. So the standard size normally is these 0.254 millimeters or 10 mil, which can handle almost an amp, and this is more than enough for pretty much all stuff that we do for small voltages. But you can go a little bit higher, like 12 mil, and then you can handle probably 1 or more, 1.2 or 1.1 amps more. Step number 5, generate the Gerber files. So you can use Gerber Viewer to check the results. So you are going to generate the files that you're going to send to the manufacturer, and they have those files have like information about the top and the bottom copper, which here are the red and the blue lines, the traces. And then you have the top and the bottom silk screen. It's not represented in this example, but this is like text or graphics that you have on the boards, like indicating the pins and things like that. And then you have the top and the bottom solder mask. This is to guarantee that the pins, when you're soldering, you don't short circuit pins together. And then board layout, like size and shapes. And then the drills files, in this case like the yellow and gray circles here is where the machine is going to drill if you have the through-hole packages or vias. This is where the machine is going to drill the holes. Step number 6, PCB order. Once you have those Gerber files, you go to a website. I'm giving you here 2 websites that I use a lot. One is in China, another one is in US. There are pros and cons as always in using one or the other, but both have very good quality and you'll be happy by ordering on these places. So you order your PCB boards. After a week or 2 weeks you get your boards, and then you solder your components to your board. And then depending on your choices that you did on your step number 2, you need to solder those components in different ways. And this video is going to give you kind of some guidelines on how to solder all these components. Probably like these through hole and dips are probably the easiest ones to solder. Surface mounting depends on the size. If it starts getting too small, it becomes harder. You probably need to use an oven to help you with that. Otherwise, you can use a solder iron. And then these ones, depending also on the number of pins and how things are connected in your PCB board, you can use either a solder iron or an oven to solder your components. The second tutorial that we have is from Jeremy Blum, and he's going to develop a project in Eagle, which is a blinking board. It uses a 555 timer with some passive components, some resistors and LEDs. And then it's just going to blink. It's going to set up this timer in a stable mode. It's just going to blink the LEDs back and forth, and the power is from a coil cell battery. So video number 1, it's a 30-minute video, and you guys should follow so you can learn how to use Eagle, the software, and build this schematic. And then video number 2, he goes and he teaches how to do the PCB layout, also a 30-minute video. And then video number 3, he goes and he teaches how to generate those Gerber files that you're going to submit to the manufacturer.